So to begin our discussion today, we're going to be discussing area and volume. Shown here we have formulae that we use for the entirety of the chapter. So for the circle, we have an area formula, a perimeter formula, but in 3 dimensions, a circle has no volume. We have an arc or a sector, square, triangle, and then we can move on to 3D shapes such as cube, cuboids, prisms, cylinders, and cones. So let's get straight into some examples. So we're asked to find the perimeter of this shape. To do this, we're going to have to split the shape into 2 so that we can find the perimeter here. So to do this, we need to split this shape into 2 sections so that we can find this x here. So in doing so, this side is going to be the same length because it is a rectangle. And so then we can use Pythagoras. We have 12 as the total length here, and this here is 6, so clearly when we take away the 6 from that, we're going to end up with a side length here of 6. Using Pythagoras down here, we have h squared equals a squared plus b squared. H squared is 6 squared plus 8 squared, which works out to be 100, and then taking the root on both sides, we have h equals 10. We then have 10 here, so all we need to do is sum together 10 plus 12 plus 8 plus 6, and we get 36 units. So taking into account something that you may see with regard to circles. So we have this here, we're told that the arc in the center of this sector subtends an angle of 60 degrees. We're told that the area of this sector is 36 pi, so we need to find the radius. So when we're talking about the area of a sector, this area of a sector is always going to be pi r squared times whatever angle you have over 360. So you can think of it as a fraction of the total circle. So we let this formula here equal to the area we're given, 36 pi. So that'll give us pi r squared times 60 over 360 equals 36 pi. Cancel out the pi's. 60 over 360 will simplify down to 1 over 6. R squared over 6 equals 36. We can then take the root, and just doing a little bit of surds here just to demonstrate how it's done. Root 216, that can be split up into root 36 multiplied by 6. We then have root 36 is 6, so then this can be written as 6 here, leaving us with 6 root 6. Our next example here is a polythene tunnel. So let's say it has a radius of 2 meters and 5 poles here to here that are 2 meters apart. So there's our radius and our length. So there's 4 sections, 2 meters long, and the tunnel is, as a result, 8 meters long. We have 2 radii will give the width of the tunnel, so it's 4 meters wide. So then the area covered is rectangular. Simple as that. All we have to do then is multiply length by width, so 8 by 4, 32 meters squared. So if we're asked how many meters of steel we need to use to make the tunnel, so we can do this by constructing 5 half circles, and these are just covered in a polythene sheet and so on. So each of those circles is a 2 meter radius, and a circle with a circumference of 2 pi r will give us the total. So we have a half circle. A regular circle has the circumference of 2 pi r, so obviously a half circle is going to have length pi times r. So the length of each single pole is going to be pi times the radius, so pi times 2. So we've got 2 pi, and then since we've 5 of them, we need 10 pi meters, which is going to be approximately equal to 31.4 meters. So let's say we're then asked that the polythene has to be buried 25 centimeters deep into the ground. How much polythene are we going to need to cover the entire tunnel, assuming that both ends are left open? Okay, so if we take a look at what we need to cover the entire area, covering each of the poles. Okay, so this sheet here will fold out like so. So we know that the length of this here is 2 pi. We know that the length here is 8 from back here. So then we have 16 pi as the length of this. However, so then we have 16 pi as the width of this. So then we have 16 pi as the area of the sheet that we can see above ground. But there is a certain amount underground as well. So on both sides, there's an extra wing attached on. It's 8 meters long, as is the rest of it, but it's buried 0.25 of a meter into the ground. So we need to add on 2 times 0.25 by 8. So that gives us 2 pi. So that gives us 16 pi plus 4 meters squared. The last example that I want to discuss involves 2 cubes that are sat on top of each other. So we're asked to find the total surface area involved. Now, doing this, we're going to have to find the total surface area of this lower cube. So that's fairly simple. Side length 2 meters. We're just going to go 2 by 2. That gives us the total area for one side. Multiply that by 6 will get us the total area for the whole cube. Now, however, one side of this, namely this side here, is hidden by the upper part, or it's hidden by the lower part of this box. So to do that, all we need to do is just subtract a 1 here, seeing as the side area here will be 1 times 1. Then all we need to do is add together 1 times 1, so that will be the area of one side of this, and then multiply that by 5, seeing as we only have 5 sides of this showing. So that'll give us 6 by 4, subtract 1 for this part, plus 5. Total area is going to be 28 meters squared. Now, we're then asked to find the length of BC. To find the length of BC, all we need to do is look at the base. This base here. In doing so, all we need to do to find the length of BC is use Pythagoras. So the length of BC squared is a squared plus b squared. It's 2 squared plus 2 squared, so it's going to be 8. And then taking the root on both sides, you're going to get 2 root 2. Of course, root 8 you can write as root 4 by 2, which you can then separate into root 4 times root 2, which is then 2 root 2, which is where this comes from. Finally, we're asked to find AC. So if you look over here on the right side, we've drawn a little bit of a diagram to show how we find AC. So if you look, from B to A is a straight line upwards. It's going to be 2 plus 1. So AB is going to be 3. Similarly, we've just found BC. We've just found BC to be 2 root 2. So now if we look, we can connect A to C through a diagonal line through both boxes, like so. So in doing that, we construct this triangle, this triangular shape here, and that's given here. Side length 3, side length 2 root 2. Again, all we need to use is Pythagoras, so AC squared equals 3 squared plus 2 root 2 squared. We get 9 plus 8. AC squared equals 17. Taking the root of that, AC is going to be root 17.